Eric, please, the floor is yours. I want to share your screen.
Sure. Thanks, Marco. Thanks, Marcelo. Hello, everyone. Very glad to be back to the Tiny Machine Learning workshop. And I always feel very cozy to coming back and do the sharings because it's such a great community with a lot of passion and a lot of curiosities. So today I'm going to show you very early experiments, and nothing is guaranteed to work for most of the demos. But I like to answer any questions to share what are the progresses we have made. So today I'm going to talk about tiny machine learning for sure, but how to bridge it with physical GPT. There are a lot of interesting convergences happening. And first, for people who don't know us, we are City Studio. We have building open source hardware from 2008. We try to bring technologies open source and to provide to the global maker community. In the beginning, we help people to create more productive possibilities. Then after many years, we start to think, okay, how can we help people to move onwards? How can we help makers to really resolve real life issues? So we come up with more devices ready to be used, but still keep them open and keep them accessible. And this year we have changed our slogan a little bit. Previously we called ourselves the IoT hardware partner, but as AI is eating everything and AI is embedded into most of our stuff, we now change a little bit to the AI hardware partner. So we're not only a provider or supplier, but we are partnering with a lot of makers, technology companies to bring the ideas all the way to reality. So our business model has been like this for 15 years, is we keep talking with tech companies, small or big, and to bring their what they create into a modular, open source, and easy to use manners. And then we curate all the services and solutions to make them ready to be used. And what we are passionate as many years is we see people resolving problems in reality and bring all the new possibilities into the real industries. And yes, we all work with all kinds of open source projects, Arduino, Board. Now, this last year we work a lot with the Home Assistant because we feel it's not only for consumers, it's for a lot of people trying to build smarter spaces, like for offices, manufacturing floors. And we work a lot with NVIDIA from the Jetson series, and of course, Raspberry Pi, and we have SenseCAP for sensors and Web3 projects and tiny machine learning. So these are the noteworthy like attentions we have with the industry partners. So let's start with things you are already very familiar with is tiny machine learning. How do we add AI to almost anything by making them smaller, easier, lower power, and multi-model? And important factor is becoming cheaper and cheaper. So as of the between last sharings in the tiny machine learning workshop, what we see is the microcontrollers are becoming faster and lower power. Last year we have the Groove Vision, which is like 2.5 frame per second inferencing. But now this time with M55 and the U55 architecture, and it can reach like 30 frame per second. It's like 44 times faster. And comparing to Xiao S3, if you have used, it's like 5 frame per second. It's also like 6 times. So there's a lot of things happening on the speed, but also the energy efficiency has been lowered a lot. If we see a comparable computing power from Raspberry Pi, it's costing like 3.7 watt, but now it's only 0.35 watt for the new architecture. It's much faster and lower power. And we have more dedicated benchmarkings and we list all the details in this page. And you can see we try to evaluate our products and we assess the popular products as well to see what's the balance because different scenarios you might different like tiny machine learning solutions. And we are keep coming up with more tiny machine learning microcontrollers because of the microcontroller companies equip everything with NPU with machine learning capabilities. And we just follow up with them and try to make them easier and to unite more people to use. And there's one interesting usage is to use it for as a voice like a recognizer for large language models, and we might share later. And I think a good lesson from last workshop is we see Jeremy is using a JavaScript to make all the trainings easier and by click and process manner. And we start to think, okay, it's tiny machine learning is becoming more accessible. It's easier thanks to aging powers, thanks to all the tools. But there's still a big portion of the Arduino users or a big portion of the makers hasn't started to use AI because it's still too frightening. So we have invested a lot of resources to make sure people can, even with no code, they can do machine learnings and do the maintenance operations on the fly. I think it's an ongoing process. It's easy to train for the first time, but if you want to bring it to real usage, you have to use a lot of popular models. You have to on the fly to change it. And for now, I think it's still too difficult. It's okay if you're making a device that manufacturer for like 10,000 times. But if you're just creating one solution for people with less technical skills, you need more like no code, easy to use machine learning ops. So what we did is to use build a web server inside the microcontrollers or to bridge it with Node-RED. So you can see from the right one, we in our office, we just use S3 with a Groove Vision AI, and we can do a people counting system. This is alive in our office that can see how many people has entered, exit, and we transform that into a web-based way as well. You can choose different models, and we embed some very simple calculations. But because of the simple calculations, you can just have a result. You can see the full like tiny machine learning system as one single sensor that can generate some data through UART or I2C. So we hope this can enable more people. Don't be afraid of tiny machine learnings. It's just you start to use it for like person detections. You don't need to train for yourself. Like post detections is quite a mature, but try to use it for real actions as a jump start. And also we find that the way to talk to tiny machine learning things is becoming pervasive. Like we have a demo to use Telegram. You can just talk to your objects. If you add a tiny machine learning into something, you can just show me the picture, just show or help me to do something. What we need to do is to make the firmware more easier, open, flexible, so people can have their own intelligence into that. So this is earlier experiment last year. We correct me if it's the wrong direction, but we are trying to make everything like you can talk with in more intelligent way. Maybe in the future you can have group talking, or maybe in our room meetings you can have more objects to present their perceptions. And we have done a lot of sensors. So very natively we look at multi-models. How can we use different kind of sensors with vision, with sound, or remix them to compile for something more contextual? And of course, some modules are not enough to deploy in the wild. Like we were talking about a flood, we are talking about all the heavy rains, snows. But how do you send this data, send the sensors outside? How do you deploy the AI sensors outside? So we are building a new device. It's called a SenseCap outdoor combo. Try to make it everything into one piece and independent. And it will have shell inside as well to becoming the AI engine for our multi-model sensors. You can do many things or just transmit all the data back. But hopefully, I think with all your help or other partners like scientists, we can make this as some local prediction models, like with LSTM, long short time model to estimate or to form out with a swarm AI sensors that you can do more precise predictions on top of the large area prediction models. There's many things we have been thinking about. Like last time Marco was in our office, it's my first time I realized how important the weather station is for a lot of developing countries. And I think in climate change, maybe we can do a lot more with more sensors and AI. And also, what's next? For dynamic machine learning, the most important and fresh ideas we are experimenting is with few shot training. And maybe you have tried this already. It's called a YOLO word. You get inspired by that a lot. You just go to Hugging Face, you upload a picture or use a camera to record your surroundings. And you can just add if it's GPT, you prompt, you ask, do you see people? Do you see a breadboard or whatever? You just ask to it. And if you can see from the little sentence here, it's also trying to understand. It says people sitting in a room with tables and chairs and a projector screen. There's no big large language models underneath. It's just YOLO. But this team, they have trained the images with the text to form a new complete machine learning model. And what we are doing on top of this is for desktop, this is for PC. And we are building a tool. It's not ready yet. We will show you as soon as possible. Is whenever you can, from this YOLO word, you get a subset of the models you want to use and deploy that onto your tiny machine learning models. So that can save a lot of trainings because YOLO is quite a mature that you just pick whatever you want according to your scenarios and you can update on the fly. Okay, so this is the most exciting and the most challenging things for us to find out in the machine learning model. For us, City is not a very expert in machine learning. We are just the integrator to make them easier to use. So feel free to challenge us if there is any mistake or any other suggestion to make them easier. And also, because we're doing a lot of edge devices, very naturally, we are looking at generative AI and how to bring them into edge. So every week or every 2 weeks, you see from the news that there is a better, stronger, more powerful GPT coming out. There's a 40 trillion like parameters and or more. But we don't, it's okay. I think it will go on. But I think for us is we look at other end. Can it be smaller? Can it be distributed, deployed? It can be your local GPT. Can it be your GPT for this office or classroom? So can it ingest more like information with multi-model with different image from real world? Can it combine with sensors or speeches? And we are doing our efforts to make it cheaper. Like on NVIDIA Jetson, we have a recomputer GS3011. It cost is just $599, which means less than $600 you can have your own GPT running Llama 7B. I'll show you the ratings later. And this opens a lot of doors to robots, to like different scenario applications when there is no cloud facility or the infrastructure is break down. You can just send a box of all the intelligence to wherever needed. And also there's a very easy to use tool, easier and easier to use tool called RAG. You can turn the localized GPT towards your context. And also you can even build that into agent to control your systems. Imagine you have legacy system of home automation or from electricities. Now you can talk to it. So we are also, again, passionate about this idea and we do some experimenting. And this is our legacy. We have built in AI box for 5 years. Now, from the edge AI, instead of a server, you can use a very small box and reach up to 275 tops, or a small entry-level one listed about 50 or 40 tops. You can do a lot of things with them, no matter it's AI vision or it's GPT. We're talking about the GPT today. And this is an example from Dustin. He's evangelist for NVIDIA. Yeah, please make sure to check out the website. It's called Jackson AI Lab. And he's keeping looking at all the large language models and turn them in, optimize them for JSON-based operation. And this one is called Lava. It's trying to describe the next vision model is trying to describe what's in front of this camera, what's inside this picture. So you can see it can go into a lot of depths to understand the real meaning as a human being or more than that. And the speed is much better these days. Like you can see from Lava, it's about 1 frame per second. But with Villa, a new model, it's just a 3 billion parameters. It can reach 7 like inferencing per second. It's as if you can almost inference live video with large vision model to understand the deep perception of that video feed. And also, look if you look at the text generation model, which is a more traditional way, it can run like Llama 2, 70 and 75 token per second. That's quite beyond people's expectations on the edge on a small device. So this experiment goes on, and every time I show this, it's outdated. Please go to the sources to know all the craziness. But why? There's several reasons why you try to benchmark with the local GPT or versus the OpenAI or other like cloud of infrastructures. If you have very like scarce usage, like once per hour, you surely use the cloud ones. But if you want to inference video feeds, you want to inference multiple like video sources, or you want to have privacy, you want high response time, you should have the local GPT. That's a possibility. It's not a must, but you have the possibility now. And on top of the people's constructions, we construct in our office. In our office from last year, we try to hack our offices with our staff or other people's staff to make it into a smart office with a home assistant. The result is we have 2-floor buildings, we have 200 people, then we have 100 devices. But how do you use a dashboard to manage 100 devices? You go to any like place you want to turn on the automations in that room. It's still like a mess. You need to deal with a lot of complexities. So what if we can have GPT in front of that? On the complex system, it has all the rules and also JSON configurations, HTML files. But later GPT with RAG, with a tool called LangChain, to understand what's happening and illuminate the most closed actions you want. So by doing that, it can help you to execute the commands with all the API. In the front, you can have a GPT with the vision, with a video. If like there's no people in the meeting room for more than 2 hours, just turn off everything. Or if like on office hours, you see someone goes in without protection to the manufacturing floor, you should do something, send up some warnings and that kind of stuff. You can just talk to it, and then it decode that into actions, SOPs, and confirm with you and execute. It's not fully like ready, but we make it working. And it's an open source project. If you go to GitHub, you can see it's called local Javis. And it's not, there's so many ideas. It's not fully like on pipeline yet. Like in the front, you can just talk to it. You can have a Riva. You can use different languages, and even you can embed that into one robot or multiple robots. So I feel the local intelligence is pretty good that you can play with them differently these days. Okay, yes, so we think it's becoming a new generation of human-machine interface, and we poke our designer friends a lot. Now it's time for you to rethink how do you interact with machines. It's not a screen and touch. With this GPT, you can really just talk to things, or it should be proactively help you to do things in a good way. So these two areas started convergence a lot, and there's a very popular ideas now. It's called embodied AI, and we see a lot of popular AI projects like the AI Ping, Rabbit, and we see more Droid coming up. And but we care a lot is how can we, like especially for the maker community, instead of building one device to fit everything, how can we enable more people to have the capabilities, templates to build them like next generation human machine interface? How can we upgrade the legacy machines? How can we digest all the data with embodied AI? So that's the direction we are going. We feel this is a perfect match because with tiny machine learning in the front, you can pervasively, with no power, with no cost, to understand, to filter many events from the data you get the events. For example, you with a camera with tiny machine learning, just looking at an area. If there's no person, you don't need to do anything. If there's a person, it will send the data back to a large vision model. So large vision models can sleep for most of the time, or they can support multiple hundreds of tiny machine learning devices to enrich them with context and to connect to a legacy system to control that. We see this is very powerful. Tiny machine learning devices, they are pervasive, but they are not strong enough. But if we combine them into this kind of manners, it can be greatly enriched. So we feel it's rhapsody of tiny machine learning and the local large language models. Then this year, earlier last month, we have a new device, we call it a SenseCap Watcher, because we think maybe it's time to think how can we have an AI agent in the physical world. It's not for your like a personal assistant. It's not for yourself. It could be for your machines. It could be for your for your spaces, for your parks, for your hospitals, to make these spaces smarter by enabling the visitors or other users to be able to talk to it. They might not be technically savvy, but they should be very with intuitions, very naturally to talk to a machine that help them to get information, help them to execute a lot of the behavior they wanted. But also by doing that, we can save a lot of staff to the serving, to all the expertise in training. So this is a simple device. We'll probably shipping the beta units next month. Please let us know if you are interested. As a camera, as a screen, it has M55 architecture AI inside, so you can perfectly do tiny machine learning models. And it's open source, and you can remix into different form factor and connect to different system. And we will build a template for even designers to be able to change the behaviors. And here's a very short demo, very short one. Yeah, there's been more demos, more like source code be shared later. But what's underneath is like a repeating what we have been seeing, tiny machine learning in the front to do all the inferencing in a no cost, no power consumption way. Then send the data back to a local large language model server or to the OpenAI or other online GPT. So you can basically like talk to a very small but smart system. Okay, maybe, and also to deploy and the training that should be easy. You should be able to add like a prompt, like agent. You give it a context, ask it to do things you want with the right authority. So what's beyond that? This is the most exciting like slide I have actually. With tiny machine learning models, now you can have more meaningful data. You don't need to send everything back to the cloud to waste a lot of energy and communication data. But now you can just get all the events. But with the generative AI, you can understand the data in a collective way. Maybe in the future, you should have a farm GPT. You should have flood GPT. You should have a like flood GPT for the South Brazil. You can have more localized, specialized GPT with the help of RAG, with all the open source like frameworks. Then this generative AI can give guidances to the local people. So I just need to share my data or use other people's data and consult the GPT. Should I go out? Should I like harvest my crops, or should I do something to things I'm not so expert at? Because the GPT, with the help of the real experts, can give me a very no cost, very no marginal cost consultancies. And by with the tiny machine learning with IoT, we can feed more real world data to GPT. I think this loop can go on. And this can be a bridge between science and applications. Like we were sharing last time in Italy, is the scientists can get more data from the real world. And if we close the loop, the farmers or the workers or the practitioners, they can, by receiving the consultancy, they can contribute the data back. And all these things we can done without one single company to master them, or it can be in a very like how to say collective manners. It can be done locally. It can be done distributedly. Everybody can share and contribute to that. And this also reminds me of one contest we have done in 2022. It's called IoT to the Wild contest. And during that, we sent out 200 like AI plus LoRa sensors to like a global applicants. We see a lot of good ideas like flash flood, algae of the on the lake. Then we are thinking, okay, now the technology has been getting more mature. Maybe it's time for us to talk to these people. Okay, should we have more AI and GPT? Should I have more science versus application to your deeds? So I think a lot of this climate may change or the disasters to remind us to think, okay, because the world is not static. Maybe it's time to use AI to adapt all the changes to get more real-time manners. So City is very open, no matter our hardware, our products, but we are also looking for co-inventions. We call it co-create. We have the hardware can help you to make the hardware, and then we can deliver the solutions in an open way or in what kind of business manners to more sustainable community. And that's it. Let's keep talking. You have my email here, and you can easily find me on LinkedIn or any other.
Great talk. Thanks a lot.
Great talk, but I cannot see Eric. Oh, there you go again. Okay, okay, super. Thank you so much,
Here.
Eric. That was absolutely fantastic. And yeah, on behalf of the organizers, thank you very much. Any questions for Eric?
I think there's one in the chat from Ahmed Mohammed. Is what do you need MLOps for hyperparameter analysis like for NN?
So it's like DevOps. You have the
MLOps.
development done. You can see here. If you have development, you have the firmware done, but how do you send out it to the field? And then how do you collect it back? So we are trying to build a loop between the development and operations to shorten the process to really deploy a machine learning models. Okay, maybe this is too much like IT terms. It's in a simple word, it's just making machine learning ready to use, and it can be updated whenever needed.
And there is a second one from Mohammed Azan. Can I get the data of that one meeting in PDF form? In that way, it's easy to again prepare that one for.
Yeah, I'm confused about that question.
Yeah,
yeah. So
it's for Eric. I don't know.
Yeah, Mohammed, if you want to unmute yourself and maybe explain better what you have in mind, you can do that now. In the meantime, while Mohammed unmutes himself, I have a question for you, Eric. So what about the kind of these two environments? I mean, this kind of TinyML and ML on the edge and the communication side. So how do you integrate this system with the LoRaWAN networks, for example? Or do you foresee using Wi-Fi more than LoRaWAN?
So LoRaWAN is pick up very fast, and we think it's the coolest combination between tiny machine learning and LoRa, because you can squeeze the data. You can because tiny machine learning can be the ultimate compressor for data. Then you send a very short message to LoRa. So this is perfect combination. But as any technology, it needs some time to get adapted for the market to understand or set up the infrastructures. So all the sensors we have LoRa, but of course it's easy to connect to other connectivities like Wi-Fi. Most of the shell has Wi-Fi on board, or even Matter. Then you can have Bluetooth. You can have connect to a GPS model, 4G model. So it should be pervasive. I think for showcase the technology possibilities, LoRa plus tiny machine learning is the default for us.
Yes, yes, definitely.
Okay.
So there's one question from Jose Luis. how did you fuse all these different information sensor sources? Which multimodal strategies do you suggest? And there was a question about this yesterday as well. I think it's really good too.
We don't see some very good how the infrastructure yet. Maybe it's just didn't come to our vision. But what we see is one single way is it's easily to help you to tag the data. And also you can have AOSDM. You don't care what kind of sensor data it is. You can just fuse them together and tag events and train that. But I think we can also always, with GPT, we can always do a lazy way. We try that is you just send all the data to GPT and let it try to come up with some solution for you. And in the future, I believe in a spatial area, there should be some specialized GPT to help you to cluster this data or to find out the abnormalities inside the sensors. Or you can use like image sensor to tag all the like color sensors or like gas sensors because different elements they have one event have different aspect of elements. So this is our understanding of multi-model. It's not only the GPT way of multi-model. Now you have image, you have sound. I think for our IoT world, you have too many sensors around you. You can see from the picture the earth is dry, but from moisture sensor, it's already reading 0. So you can very easily match them. And then you remove the cameras, you can have the data.
Mm-hmm.
Yep. What is the data?
Question about integrating IoT and TinyML.
Yeah, I think if you don't, it's not mandatory. If you have only one microcontroller, you have the sensors, you can do that on the fly and maybe blink a LED or to control some actuators that's already forming a tiny machine learning enabled automation system. But with IoT, you can connect more of this automation together. So that's what's the rate of treatment data for a prediction that varies. I think that rise according to the frequency of the events. If it's happening, it's changing very fast, you need more data. If it's very slowly, like temperature change or the light change, you can see the data with hours. Pre-model defined. This is not actually a trained model. There are several, it's kind of old machine learning models, but it's not properly addressed in tiny machine learning yet. So I have on my very like a few projects I tried that a few years ago, but in the future we can build up open source project to support that. But I believe this we can just build the system, but maybe the data scientists or machine learning experts they can help to re-engineer that towards the specified prediction model. If it's a you might need to do a lot of deep engineering to make them efficient. But I think the most important one for that is the data. How do you verify? Because, for example, we wanted to verify if according to the moisture level change, the blossom is coming. But to verify that, you might need a growth period, which means maybe a few weeks to see this happening. So it's not like detecting a face. You can show 1,000 faces easily. You might need 1,000 fields, 1,000 times of crops blossoming to see to have meaningful data to train.
Eric, I have a question. For example,
Please.
So your vision is, for example, you can have like a TinyML device like this that, for example, to detect a person. So you don't need the energy, etc. So the person is detected. You can move for a small language model like Java or Villa, as you comment, and what this guy you say like say, oh, this is a guy with bird with a white shirt. So from this, let's say, sentence, you take the information to send for a robot system or a home assistant to do something. That's the idea, to extract from the words. That's the idea.
It's actually done in 2 stages. First, the tiny machine learning is taking a picture of the keyframe and send that picture to the large language model on the cloud or on the edge. So the large language model will ingest that picture and come up with descriptions. And the description can be, you can train it. You can ask it to let me know, like on that demo was help me to describe what's happening here. Or you can also describe, let me know what's written on that whiteboard.
Okay.
So you can give it a very specified tasks, and you can then use that tasks, that results to drive some actuators. For example, you can ask a question if you see some white beard professor with the earphone on, then turn on or turn off the curtain.
Okay.
So it can be a very definite instruction to automation system.
Understand? Well, it's no,
So
yeah, it's amazing. Yeah.
Yeah, that's very fun part. You like I think just after 1 year, you feel you have Java on your hand. You can just try to engineer it, and it's very, very fun to play with.
Thank you.
Okay.
Super. Any other questions?
I think there are a lot of detailed questions. I will just share the slides in PDF. Maybe you can just look at on the links, and they have all the code or they are not so well documented because it's the early stage. Feel free to let us know if you have questions to the issues.
Super. And if you look at the chat, if you go up, you see that there's colleagues using Seed Studio, equipment already in Cameroon and so on and so forth. Super. Thank you so much, Eric. That was really fantastic. And if there's no more questions, then we can move to.
Okay. Yeah, and people only to remember people to go to Discord. I think that we can get more questions there, and also we can send it to Eric and to in specific question that you have, guys. So thanks, Eric. Fantastic.
Pleasure.
Yeah, and thank you for supporting this community over time. Thanks a lot.
Yeah, thanks a lot.
A pleasure.
Yeah.